Hello and welcome to lesson 4.2, Geometric Relationships. In this lesson, what we're going to do is we're going to look at some geometric relationships that you probably know and some other relationships that you may not know. So one of the relationships you should remember, based on this minds on that you see right here, is something about parallel lines. So here in this expression, you might actually be able to see the line AB is parallel to line CD. Well, if you know that, you can use things like the F pattern, C pattern, and Z pattern. You can also use the other facts that you know about angles. So, at this moment in time, I ask you to pause the video and determine which angles are the same, and also determine which angles add up to be 180 degrees. Okay, so after you've paused the video and checked this out, you should notice that angles like EFB, I'll write it like this, angle EFB, which is given by this piece right here, is equal to the angle AFG. So I'm going to use a symbol to show that these two things are the same. I'm going to use a little arc like this, and a little arc like this. These are equal due to the fact that these are opposite angles. We also know EFB is equal to angle EGD due to the F pattern. So these two are the same. So we can also state that angle EFB is equal to angle FGD. Now we don't have to keep stating all angles that are equal in this format. We can just write it on as symbol notation on our graph. Something else you might remember is something called the Z pattern. So you can also see angle AFG is equal to angle FGD by the Z pattern. And likewise, you can also see that this angle, this angle CGH is equal to all those other angles. Again, by opposite angles, or F pattern, or Z pattern, whatever you'd like to use. Now you can also see that if you have a straight line, so I'm going to draw it in blue, two angles or three angles, all the angles that add up to be a straight line equals 180 degrees. So in this case, you can notice the angle EFA plus the angle AFG is equal to 180 degrees. Due to this pattern, you can also notice that two angles, my apologies, erase that one. You can also notice that this angle right here and this angle right here are equal due to, again, opposite angles. Moreover, you can also see that this other angle that I also drew, I'm going to choose a different color. I'm going to draw purple. So this angle plus this one right here would also equal 180 degrees. So that's angle BFG plus angle FGD is equal to 180 degrees. This one's often referred to as the C pattern. So we have opposite angles, we have angles that have to be 180 degrees that make up a straight line. We have F pattern and C pattern. So let's look at some other properties that you know. Here we have two angles that added to be 90 degrees. That symbol right there, that square, represents a 90-degree angle. So if we know those two add up to be 90 degrees, what we can do is we can actually take the two expressions and add them up and equal it to 90 degrees. Okay, well, we can now simplify this. So 4x plus 5x is 9x. Negative 10 plus 1 is negative 9 degrees. I can add 9 degrees to both sides. And then in order to solve for x, I can divide both sides by 9. So here you can actually find out that x is 11 degrees. Okay, let's take a look at some other geometric properties. So triangle. One of the properties that you should know from grade 7 and or 8 is all the angles in a triangle add up to be 180 degrees. So that means this angle A, this little b, and this little c add up to be 180 degrees. So if you happen to know what A and B are, you can figure out what C is. Well, if you extend the line of each of these, of this triangle, like this kind of shape that you see right here, these are called exterior angles. Well, one property of these exterior angles is you might notice that A plus D equals 180 degrees, or B plus E also equals 180 degrees, or C plus F equals 180 degrees. Well, another property of these exterior angles is all exterior angles add up to be 360 degrees. If you might notice, two of these, all three of these together, if you add them all together, is 180 plus 180 plus 180 is 540. Well, 540 is 360 degrees bigger than the already established 180 degrees. And that's why D plus E plus F equals 360 degrees. You can either memorize this property or just, as you can see, calculate the expressions. Okay, now of other polygons, if you ever need to figure out how much is the interior angles of any other polygons. Let's take this polygon for instance. This polygon is called a pentagon, or five-sided figure. To find out the measure of the interior angles, what you can do is you can actually break them up into multiple triangles. So as you can see, I can create a triangle right here, and I can create a triangle right here. So what you can see is you have 1, 2, 3 triangles. So if you take your number of triangles and you multiply by 180 degrees, this will give you the measure of the interior angles. Well, you might also notice that the value 3 is actually 2 away from the number of sides. So if n represents the number of sides, then the interior angles add up to n minus 2 times 180 degrees. Well, by the same property, you might notice that all these exterior angles, I'll call this one A, this one B, C, D, and E, there are again, in relation to the interior angles, add up to be 180 degrees. All the exterior angles add up to 360 degrees still, no matter what, no matter how many sides there are. Now there is something called a regular polygon. Regular polygons have sides that are all the same size and have interior and exterior angles that are all the same size. So for instance, a square. A square is a four-sided figure, which you know has all the same side lengths, but also has all the same interior angles of 90 degrees. Well, it also has all the same exterior angles, being exactly the same size as 90 degrees. So, some other properties or constructions. In triangles, you can create various different things. Well, one of the constructions you can create is called a midpoint. And as you can probably guess, this is just a middle point. So all I have to do is grab a ruler. I'm going to grab my ruler. I'm going to measure the side length here of one of my sides and find the middle point of it. So this little red point that I've created is called a midpoint. Whereas a median is a line from a vertex to a midpoint. Oops, sorry. So this blue line that I'm drawing right here is called a median. Whereas a mid-segment is a line from one midpoint to another. So I'm going to find another midpoint right here. Give me a moment. So there's a midpoint on that. So this one creates a mid-segment. These are constructions in triangles that you will need to create and do some exploration with. Okay, so let's take a look at some other constructions. Some other constructions. A diagonal goes from a vertex, that's a line, to an opposite vertex. So I'll never actually go to one vertex to another side. So for instance, this line that I've drawn right here is called a diagonal. Oops, we've already gone through the construction of midpoint, so I'm going to find a midpoint of one side. And I'm going to find a midpoint of another side. Well, a bimedian actually goes from a midpoint, sorry, my apologies, it is a line from one midpoint to an opposite midpoint. So this red line that I've drawn here is called a bimedian. So these are some constructions that you will get to know to do. Okay, some other constructions that we need to know. Some constructions in circles. So first construction we'll take a look at is a chord. A chord goes from is a line from one point on the circle to another point. On the circle. So, for instance, I'm going to draw a point right here, I'm going to draw a point right here. This line that I'm drawing right here is called a chord. Now you could draw your chord so that it goes right through the center of the circle. This item is called their diameter. Which also gives you partly your radius, which is just half the distance. An arc is a curved line along the edge of a circle. Sorry, part of a circle. So for instance, to go from that point to this point, this blue curve right here is called an arc. Okay. Last but not least, another construction inside a circle is an angle in a semicircle. So a semicircle would go right through the center, and this would create our diameter. Well, this angle right here, because it creates a semicircle, this angle is 180 degrees. So some other constructions inside circles that we need to know. We also need to know something called a central angle. So a central angle is an angle that uses the center as one of the vertices, as the central vertex. So let's say this right here this one will be our central angle, which I'm going to call X. Well, an inscribed angle turns out to have the same vertices as a central angle, except for the center angle. So I don't need those brackets. So it takes on any other point along the edge of a circle and shares the same vertices as the central angle. What you'll notice is we'll call this angle y. Well, there is a relationship between the measurement x and the measurement y, and you can prove this for yourself if you like. What you'll notice is 2y's is equal to 1x. Or, if you wish, y is equal to half of x. Okay, one last construction. Last construction is actually outside of a circle, and it is called a tangent. A tangent is a line that touches only one point on the edge of a circle and is perpendicular to the radius. So let me draw first of all a radius. You can see the center of this circle, and here's a radius. So now we draw something, my apologies. Now we're going to draw something that is perpendicular to that radius. So this line that I've drawn right here is called a tangent. So based on all these constructions that we've created today and all these measurement geometric relationships that we've seen today, you can complete any part of your homework. And thus concludes this lesson.